Greetings, chemistry students. Mr. R again. We're on chapter 10. You find it on page 310 of your textbook. What we're talking about is the mole. Now, the mole is a quantity. Just like a ream of paper is a quantity. Well, how much is it? What's the amount? What is the amount of that quantity? Well, a ream of paper is 500 sheets, or a gross of pencils, or a gross of bottle rockets is 144 pieces. All right? Now, a dozen is 12. So, a mole is a quantity. It is 6.02 times 10 to the 23rd atoms or pieces. We're talking chemistry, so we're interested in atoms or compounds of the pieces. So another name for 6.02 times 10 to the 23rd is Avogadro's number. So Avogadro is the one that came up with 6.02 times 10 to the 23rd. That's how many atoms there are in one mole. All right? Just like a bushel is a quantity of fruit or veg, about what somebody could hold, and I believe it's 8 gallons. And it's a basket. It's a basket of 8 gallons. It's about what one person can hold of corn or of apples. And a dozen eggs is a normal amount of eggs. A gross of something for those pieces, it's normal to have a gross of them, or 144 of them. And it's normal to measure atoms in units called moles because there's so many of them. We need a name for a quantity that makes sense. And this number is such a big number that it's very, very difficult to wrap our heads around it. But let's talk in more specifics. Let's talk more specific. A mole is any substance always containing 6.02 times 10 to the 23rd particles. So you could have a mole of anything. You can have a mole of jelly beans. You can have a mole of marshmallows. But we're specifically interested, just like you can have a dozen eggs, or you can have a dozen marshmallows. You could have a mole of any substance. We're interested in moles of elements. First, magnesium. If I have 1 mole of magnesium, I have 6.02 times 10 to the 23rd atoms of magnesium. If I have 1.25 times 10 to the 23rd atoms of magnesium, how many moles do I have? Well, if I have 1.25 times 10 to the 23rd atoms of magnesium, and I said that 1 mole of magnesium is 6.02 times 10 to the 23rd atoms of magnesium. This fraction equals 1, so we can put it over one another. And so what I would do is, I have 3 sig figs here, 3 sig figs. What I would do is I would put into my calculator, I would take 1.25 times 10 times 10, and then double E to the 23rd, and I would have to divide that by 6.02 times 10 to the 23rd, and I would get 0.208. 3 sig figs, 3 sig figs, 3 sig figs, so that would be 0.208 moles of magnesium. And that makes sense because we don't have we don't have a whole mole here, do we? We have much less than 1 mole. We have a fraction of a mole. And that makes sense because we only have 1.25 times 10 to the 23rd as opposed to 6. 6 is 1, but we only have 1.25. So 0.2 is reasonable. So 0.2 is a reasonable answer. So if I have 2.3 moles of magnesium, how many atoms do I have? Well, 2.3 moles of magnesium equals 6.02 times 10 to the 23rd atoms of magnesium to every 1 mole of magnesium. And I want moles of magnesium to cancel, just like I want atoms of magnesium to cancel up here, so that I end with moles. Here I want to end with atoms, I don't want to end with moles, so that's why I have to have them, that's why I have to arrange my equation the way I did. And so then I would have 2.3 times 6.02 times 10 to the 23rd, and that gives me 1.38 times 10 to the 24th atoms. So if you look at this, I don't have 1 mole, I have twice as many moles. Well, 2.3 times as many moles. So that's why I multiplied. And so 6.02 times 2 is, well, 6 times 2 is 12. So this is 13. That makes sense that this is a bigger number because I don't have 1 mole, I have 2 moles. And so this answer makes sense. And so after you're finished, it's always a good idea to look at your answer, analyze it, and make sure it makes sense.